So for this question, we have a system of linear equations. A couple things that are noteworthy. Instead of using x and y, they're using p and t, which isn't a big deal, but it's something to note. And then also, they're not both in standard form. And actually, a third part is that the answer options aren't all just ordered pairs. A and b does provide actual values, whereas c and d are what we call the special cases of either infinite solutions or no solution. So if we go to our program, solve systems, it may or may not work for this problem because if the answer is either infinite solutions or no solution, we'll just get an error message in here, which would only give us a 50-50 chance of getting it right at that point. If it's one of these two, great, we can get it right. However, we do first need to get them both in standard form. So let's look at how that plays out. However, for me, Desmos is going to be a preferred method on this question. Now, keep in mind, they're using p and t. We'll consider the p's equivalent to x's and the t's equivalent to y's. And this first equation is in standard form, which is great. The bottom one is pretty easy to get in standard form. We just need to move this t term over and combine like terms so that now we have 8p plus 4t equals 12. And we could go ahead and type these in. So let's go ahead and put in the coefficients. We have 4. Make sure with this one being -2, use the negative key right here. So -2 and 6. And then for the bottom equation, we have 8, 4, and 12. Now in this case, we did get an ordered pair, which is 3/2, 0, making the correct answer A. However, keep in mind, if we would have gotten an error message here, we would have only known it's either C or D, but would have had to really do it by hand to figure out which of the two is the correct answer. Which really means that in this case, I would not use solve systems as my primary approach. I'd only use it if all the answer options are ordered pairs. Whenever I see these options, the special cases, I'm definitely going to Desmos, which we have in the upper right corner of our software, just like it is in Blue Book for you. If you had any equations, you'd want to go ahead and click the gear icon, click delete all, and then we would type these in. Now, sometimes you need to rearrange your screen. Maybe that's pressing Control- to zoom out a little bit. Maybe it's dragging the screen if you have a touch screen, and we'll go ahead and type these in. I'm going to use my keypad. You could use the Desmos keypad down here. Just depends what you're more comfortable with. Now keep in mind, we got to use X and Y. We can't use P and T in here because it'll assume that there's some kind of constants and it'll create the slider option, which is not what we're looking for. So you just want to be really mindful of that. Sometimes it's helpful to go ahead and write it out so you don't forget, okay, all the P's are X's, all the T's are Y's, and then we'll go ahead and continue here. So 8X plus 6Y equals 12 plus 2Y. And when we look at the graph, we can try to find this ordered pair by clicking here. Let's get it lined up. There we go. We can see 1.5, 0. If you weren't sure what 1.5 is, you could put 1.5, click here, and you'll see that it's 3/2. You could also, of course, press 1.5 in your calculator, press enter, go to alpha y equals, and choose option 4 to go from fraction decimal or decimal to fraction. That works as well. And we still get the correct answer as A. Now, there is also the opportunity to do it algebraically, and I show you that from time to time. Just keep in mind that our two primary approaches, which we can see on the back side of page 33, so side 2, shows substitution versus elimination, where substitution is really good if either a variable is isolated or one of them has a coefficient of 1 or -1, whereas elimination is fantastic when they're both in standard form, particularly when neither of them has a variable that has a coefficient of 1 or -1, because that would produce a lot of fractions, which can be quite messy. So in this case, once I did get them into standard form, I probably would have done elimination, but again, the two approaches that are most efficient are solve systems, but because of the fact that there were two special cases, Desmos really was the best approach on this problem.